All right. Looks like we're doing Algebra 2, Lecture 11.3 and 11.4. OAS A2F11. The student will evaluate functions for given elements of the domain. Just want to talk about what the word functions and domain mean real quick. It's a little review from Algebra 1 just to kind of get your memory spurred a little bit. Function is a relation. A relation is anything that generates ordered pairs, x's and y's, so to speak. A relation is going to generate ordered pairs for which for every element of the domain, that's the set of, you're used to thinking of them as x's and y's, the domain and the range. For every element of the domain, there exists exactly one, that means only one, element of the range. So for every x value, so to speak, there's only one y value. And oftentimes when we're dealing with functions, instead of using y, we'll use a notation that tells the reader or the viewer that it's definitely a function. This reads f of x, and it's the same thing as a y for all intents and purposes. However, this tells me that what we're going to be dealing with is definitely a function. For every element of the domain, there will only be one unique element of the range. And you could use f of x or h of x or g of x, and that's how you say it, f of x, g of x, h of x, so forth and so on. They're just like y, but this information tells us it's definitely a function. And another little reminder just from Algebra 1, a function, every element of the domain, every x, has only one y associated with it here. 3 goes to -4, 2 goes to 30, 1 goes to 0. That's an example of a function. An example of something that is not a function, 3 is paired with 5. 3 is also paired with 6. This element of the domain has two different elements of the range. The range is the y's, the domain is the x's. Since it doesn't meet the definition, it's not a function, okay? What we're going to be dealing with is functions, and this notation right here is just like a y, but it's telling us that it is definitely a function. With that in mind, we're going to evaluate functions for given elements of the domain. So they're going to give us an x value, and then they're going to ask us to evaluate the function at that x value and get the corresponding y value, or in this case, it'd be a g of x value. So here we go. Here's our function. G of x is equal to 2x. We want to find g of -7. That's the x value. So I'm going to say, well, g of -7 is equal to 2 times -7. I'm going to do the arithmetic. That's equal to -14. And if I was going to write this as an ordered pair, well, before I do that, I'll just make this statement. G of -7 is equal to -14. If I'm going to write it as an ordered pair, I just write it x value, y value, so to speak. -7, -14. So g of 7 is equal to -14. That's what we're asked to do. But this could be written as an ordered pair, -7, -14. All right, here we have an h function. H of x is equal to 2x plus 4. Wants us to evaluate h for an x value of 3. So instead of x, we're going to write a 3. This is now 3, and that's going to be a 3. So here we go. H of x, h of 3 is equal to 2 times 3 plus 4. I just took my x value and plugged it in right there, and the arithmetic is simple. This will give me h of 3 is equal to 10. 2 times 3 is 6, plus 4 is 10. And if they ask you to write it as an ordered pair, it'd just be x, y, or in this case it'd be h of x. This just tells us it's definitely a function. Okay. This is the answer that we're looking for, though. They're asking us to evaluate it. That's the evaluation. Okay. This is just how you would write it as ordered pairs. Let's take a look at another one. Here's a k function, a cubed minus 3 times a. So I want to evaluate k at -5. This will be -5, plugging it in right here. -5 cubed If you're going to do this with a calculator, make sure you plug it in to use your parentheses. Minus 3 times negative 5. So I plugged in negative 5 right here and right here. Now I do the arithmetic. Negative 5 times negative 5 times negative 5 is negative 125. And this is going to be plus 15. Negative 3 times negative 5 is positive 15. And these are different signs, so I will subtract, and I'll get, and keep the sign of the one with the greater absolute value, and that would be negative, what is that, 110? So I can say K of negative 5 is equal to negative 110. And if I were going to write that as an ordered pair, it'd be ordered pair, negative 5, negative 110. Okay? Somewhere around here, I think I've got a key. Let me make sure I didn't mess that up with my arithmetic. I'm old and brain damaged. Maybe too old and brain damaged to find the key. Hey, I found the key. What do you know? 3 kVA, negative 110. Yay! Did I get the first two right? Negative 14 and 10. Yay! I'm on a roll. All this high-level arithmetic. There we go. I've got an absolute value function, it looks like. So all I'm going to do is evaluate the g function at negative 6. So wherever there's an x, I'm going to plug in a negative 6. Try not to make any mistakes with my arithmetic. So here we go. This would be g of negative 6 instead of x is equal to the absolute value of negative, I'm plugging in negative 6. So it's a double negative, this is positive, plus 1. And then there's a plus 1 outside. Remember, whenever you're dealing with absolute values, you simplify what's inside first, then you take the absolute value of it. You don't say, hey, it's all positive because it's inside the absolute value symbols. Don't do that. Simplify first, then take the absolute value of it. This would be positive 6 plus 1 is 7. So this is the absolute value of 7, which is 7. And I add 1 and I get 8. So g of negative 6 would equal 8. And if they asked you to write it as an ordered pair, it would be the ordered pair negative 6, 8. That's the x value, that's the y value, or in this case, g of x value. Alrighty. I think it's kind of straightforward there. Let's see if I got that one right. What was that, number 4? Yay, I'm on a roll. Got a couple more and we'll be done. F of x is equal to 2x plus 1. I want to evaluate it at a variable. Instead of plugging in a number here, I'm going to plug x over 2 in right here and simplify it and see what I get. So I'm looking for f of x instead of f of x. I'm looking for f of x over 2. And that's going to be equal to 2. Instead of x, I'm plugging in x over 2 plus 1. I can think of 2, this is just a thought bubble over here. I'll erase this here in just a second. But I'm thinking of 2 times x over 2 as 2 over 1 times x over 2. And these 2's will cancel. They'll leave me with x over 1, which is equal to x. So when I rewrite this, this becomes an x. So f of x over 2 is equal to x plus 1. Because these will just cancel out for this reason right here. 2 is 2 over 1 times x over 2. The 2's will cancel as long as you're multiplying. That gives me x plus 1. And so if this was written as an ordered pair, it would be x over 2, x plus 1. Right? But this is what we're looking for in this particular case. That would be our response if we were asked to evaluate it x over 2, providing I haven't made a mistake. Let's see if I made a mistake. X plus 1, yay! All right, last one. Let me erase this thought bubble over here. We've got f of a is equal to a squared minus 2a. We're going to evaluate this function at 4a. All that means is wherever we have an a, we're going to plug in 4a in parentheses, simplify it, and that'll be our response. So let's see what we get. Oops, went overboard there. So I get my board to respond. There we go. So I'm going to say f of a is this, so I want f of 4a. So that means wherever there's an a, I'm going to plug in 4a. So this is 4a squared. Make sure you put it in parentheses or the 4 won't be squared. Minus 2 times, instead of a, I'm plugging in 4a. So what used to be an a is now a 4a. And now I just simplify it. 4a times 4a, that's what 4a squared means, in parentheses, is 16a squared. Minus 2 times 4 times a is 8a. These are not like terms, so I can't combine them. Like terms by definition have the same variable and the same exponent. These don't have the same exponent, so they're not like terms. I can't simplify that any further, so I would say that f of 4a is equal to 16a squared minus 8a, and this is what we were asked for. That's the response I would be looking for in a multiple choice scenario. And let's see if I got it right. 16a squared plus 8a, yay, or minus 8a, plus 8a. Why does it say plus 8a? Did I make a mistake? Oh, in the problem, this was a negative 4a. In this problem, it was positive 4a. So I did not make a mistake. Yay. Okay, so there we go. That is evaluating functions for given elements of the domain. In each case, we were given an element of the domain, an x value, and we were to plug it into a function and get the corresponding element of the range. We were given an element of the domain, at -7. We plugged it into the function and got a corresponding element of the range. You can do this.